Hello, and welcome to this introduction to Oracle Cloud Infrastructure Data Science Model Deployment. My name is Jean-René Gauthier, and I'm a product data scientist working on the Oracle Cloud Infrastructure Data Science service. And today I'm going to walk you through a simple introduction to a brand new feature in OCI Data Science. This feature is model deployment. Model deployment gives data scientists the ability to deploy a machine learning model as an HTTP endpoint. Model deployment, just like notebook sessions or the model catalog, is entirely managed. So we take care of the infrastructure for you. You don't have to worry about provisioning VMs, doing upgrades, patching security, and whatnot. We take care of all of that for you. And you'll see what I mean in my demo in a few minutes. Once the model is stored in the model catalog, you can deploy that model through the OCI console, the OCI SDKs, the CLI, and soon through the accelerated data science SDK as well in the notebook session. It's a simple one-click deployment with no infrastructure to manage. Logs can be emitted from model deployment for custom model drift analysis, perhaps, or to get a deeper insights on the health of your model. So you may wonder at this point, how much does model deployment cost? Well, our pricing strategy is simple. You pay only for the infrastructure that your model deployment consumes. We do not add a tax or overhead on top of the infrastructure cost. The service is essentially free to use. Here's a simple architecture diagram that highlights the main component of model deployment. Let's take a look at the middle piece here. That's model deployment. So we spin up a model server in n number of VMs that you specify when you create a model deployment. For each server, we pull a copy of the model that you select from the model catalog. In addition, we pull a copy of the inference Conda environment that you want to use for your particular model. The inference Conda environment is specified when you save a model in the model catalog. You can use a data science Conda environment, so that's one of the pre-built environments that we provide in our service, or you can use a published Conda environment, which is a Conda that you've created from scratch and saved in an object storage bucket that you manage. On top of those servers, we also instantiate a load balancer that routes requests to the different VMs that are hosting the model server. The size of the load balancer bandwidth is also configurable when you create a model deployment. In addition, model deployment can also emit logs to the OCI logging service. And there are two types of logs that are captured. The access logs is a custom log that capture detailed information about the requests that are sent to the model deployment endpoint, such as the time of the request, the error codes, and other parameters. If you are experiencing problems with your model deployment, access logs are generally the first log you may want to look at. In addition, we also captured predict logs. And predict logs are a custom log that captures any logs that are emitted to standard out or standard error during the model code execution. So that includes any calls to the Python logging library, for example, that may originate from the score.py file or any other Python modules that are being used and imported in score.py. Predict logs can be used to emit a variety of useful information about your model. For example, the input feature vectors that were used to make a prediction, the model prediction itself, the prediction probability, any type of model loading errors could be captured as well. And so those logs are entirely customizable by the data scientist and machine learning engineer. Let me now walk you through a 5-minute quick start to model deployment, and I'm going to do it through the OCI console. And here you can see I'm in my in the console, the OCI console, in my project JR Sandbox. And in here, I'm going to click on Notebook Session in the resource menu here. So I have a few notebook sessions that I've created. There are models in the model catalog, and the new resource here called Model Deployments is available here. There's a couple of ways by which you can create a model deployment from the console. The first one is through the model catalog directly. So if I want to deploy one of the models that I saved in the catalog, I simply have to go through to the action menu here on the right-hand side, click on it, and you will see an option to create a deployment. So that's the first way to create a deployment, and the other one is to go through the model deployments resource and click on the create model deployment option here. So I'm going to walk you through this flow in this example. So I'm going to click on create model deployment, and this will open a window where you have to select a compartment for your deployment. You assign to it a name. I'll call it screencast deploy, a description, and I need to select first a model. So I'm going to click on the select button here, and you can select the model in a couple of different ways. The first one is by selecting a compartment and perhaps a project, and you will see a list of the models that are associated with that project in that compartment. So I can select one of those models here for deployment. Or if you happen to know the OSID of your model, you can click on the using OSID option here and paste the OSID value. And if we found it in your tenancy, we will show it here as an entry that you can select to submit. So instead, I'm just going to use one of the models here in my project that I've saved. So I'm going to click on submit here. Next step is to configure the VMs that are going to be hosting the model server. So here I'm going to click on select. You can pick first a shape name. So I'm going to pick a small shape for this purpose here. VM standard 2.1 is fine. And I'm going to use only one instance. And then optionally, you can configure logging. That's the next step. If you want to emit logs, both access and predict logs, here you have to select a log group and a log name and submit. So I'm not going to do it here. I'm going to cancel this. And then as part of the advanced options, if you click on that, you can also select the bandwidth of your load balancer. So here values vary between 10 megabits per second to 8 gigabit per second. So 10 megabit per second is fine for this example. So we filled out the value for the compartment, the name, the description. We've selected a model, selecting the compute, and we didn't select logging in this case, and then the bandwidth configuration. So we're ready to create a deployment, so we can click on submit. It takes a few minutes to create a deployment. While this is while the deployment is being created here, I wanted to go over some of the information you can see in the deployment details page. First of all, there's some general information about the deployment itself, when it was created by whom, and the OSID of the deployment. You have the information about the model that was used for the deployment, as well as the compute infrastructure that was selected. You can see the logs as well. If you have selected a log group in a log for predict and access, you will see them as being active here with the value of the name and the log group here. Work request under resource here allows you to keep track of the progress in your model deployment. So here we're creating this deployment. We're about 40% in right now. And finally, the last resource here is invoking your model. That last resource here gives you the HTTP endpoint that you can call for this particular model deployment. So you can copy that URI. And we also give you different code snippets to invoke that endpoint using the OCI CLI here, the OCI Python SDK, or the Java SDK. So you can copy those code snippets and insert them in your code. So you may need to add some configuration to your OCI tenancy before you can use model deployment. So here I'm going to go through some of the policies that you may need to add to your tenancy to get started. So I'm going to highlight a series of policies depending on the type of whether it's users or resources that you want to that we're going to control the model deployment resources. So in the left column here is if you want users of the service to create deployments and invoke the endpoint. And on the right hand side is for resources. For example, in this case, notebook sessions. Whoever has access to a particular resource can then take the identity of that resource and create model deployments or manage them or even invoke that endpoint, that model deployment endpoint. So I'm going to go through these different policies that you need to get started with model deployment. So the first one is to give the user the ability to manage models. So model deployment requires that the user has access to the models that are stored in the model catalog. So what this policy allows you to do is give a group of users the ability to manage. So manage means here execute all of the different CRUD operations on data science models that are stored in a particular compartment. And the analogous policy for a dynamic group of resources would be to allow a dynamic group, that could be a group of notebook sessions, to manage those data science model in a compartment. The second policy is to give a group of users the ability to manage model deployments. So on the left-hand side is a group of users, the same one who can manage the models, to manage a data science model deployment. So I apply all the CRUD operations on model deployments in a particular compartment. And on the right-hand side, it's the same policy, except that here we switch from group to dynamic group. And so in this case, you would give a group of model deployments the ability to create a model deployment, for example. So manages all the CRUD operations that I mentioned before. And then optionally, you can give to perhaps a different group of users the permission to only invoke the predict endpoint. So in this case, you would give this other group of users perhaps the data science model deployment predict permission for those deployments that are in a particular compartment. And similarly, you can also apply the same logic to dynamic groups and give them the same permission in a particular compartment. So those are the basic policies that you may want to create. Now, if you want to give a group of users the ability to manage the entire data science family of resources, which also includes notebook sessions and models, then you don't need to write the first two policies here. You can simply write one that says manage data science family in a particular compartment. All right. So then now let's go through a few additional optional policies that you may want to include in your tenancy. Those depend on the use case. The first one here is to give model deployment the permission to read published conda environments that are found in a particular bucket of object storage that are sitting in your tenancy. So the policy is to allow any user to read objects in a particular compartment where the principal type is data science model deployment, and in your particular bucket called, in this case, your bucket name. So you would have to replace this value with the name of your bucket where those published condas reside. So this isn't the case where you save a model to the catalog and you specify that this model should be using a particular inference environment that is published and available in your tenancy. The second policy is to give model deployment the permission to emit logs to the OCI logging service. So if you want to use access and predict logs, you need to include this policy. And this policy allows any user to use log content in tenancy where all request principal types is data science model deployment. And finally, if, for example, your deployed model needs to reach out to object storage, perhaps your model needs to read a lookup file sitting on an object storage bucket, or perhaps need to pull out a given model configuration or something like that. So you need to reach out to an object storage bucket, then this is the policy that you need to write. In essence, it is the same policy structure as you see in the first one here. But in this case, if your model needs to reach out to a file that's perhaps sitting in a different bucket, then you would have to provide a different name here for the bucket. But essentially, it is the same structure of policy. So that completes the tenancy setup portion. Now, I want to go through a slightly different use case. So this one is a, so far we've seen basically how to deploy a model from the console and how to set up a tenancy to enable model deployment. But in this section, what I'm going to do is I'm going to go through an end-to-end workload from a notebook session where I'll train a simple sklearn model. I will prepare and save the model artifact to the model catalog. I will create a model deployment using the OCI Python SDK, and finally, I will use the same SDK to invoke the model. I have one notebook example that's already running called demo notebook. So I've installed a few data science clone environments, one of which is the general machine learning for CPU. And in that clone environment, I'm running this simple notebook example that you can download from our service documentation. And so the first thing I'm doing here is to install the latest version of the OCI Python SDK. Make sure that before you run this notebook in your notebook session that you install the latest version out of PyPy. And that latest version will include, will cover the API for model deployment. So this is the first step here, is to install the OCI SDK. What I'm doing next is I'm importing scikit-learn, pandas, and a few other libraries that are available in that Kona environment. What I'm doing here is I'm creating a dummy data set that has 8 columns of 8 features, and I'm going to use that as a training data set for a random forest classifier. So it's going to be a binary classifier use case here. So I'm training a random forest classifier from scikit-learn on this training data set. And the next step is I'm using ADS to, first of all, I'm creating a directory here called MD test artifact, which is going to contain the model artifact for my random forest classifier. So I'm going to create first this directory, and I'm going to use ADS to prepare the artifact and then save the model. So first of all, there's a couple of options that you have to set up your inference environment. So your model could be using the same clone environment that you've used to train it. And so you have to, so there's 2 options here. So you can use the data science clone environment. So this would be a use case where you train the model in the clone environment, the data science clone environment, and you didn't change that environment. So in principle, for inference purposes, you could use the same clone environment. And if that's the case, you simply set the parameter to data science env equals true when you call the prepare generate model method of ADS to prepare your artifact. If you are using instead a published Conda, so you've created a Conda environment from scratch and you've saved it to your object storage bucket, in this case, you may want to use, you may want to set the inference Conda env parameter to the path, corresponding to the path of that published Conda environment in your object storage bucket. So that's the second flow here. In this case, using the ML, the general machine learning for CPU, the ML CPU v1 environment is perfectly fine for that particular notebook. So I didn't install additional libraries or anything like that. So I can use the data science environment as is. The next step will be to serialize my scikit-learn random forest object. So I'm going to just use the joblib library to do that and call that object rf.joblib, and I'm going to save that in the MD test artifact directory. And the next thing is to, I will modify a little bit the score.py file that comes with the prepare model artifact call. So I'm going to modify it to include some logging statements in it. So I'm going to create a couple of loggers to log the model prediction and the input features. So the load model is more or less the same. I didn't modify it except to add this rf.joblib reference here to load the model to memory. And in the predict function, I've added two loggers here for predictions and the model and the input feature vector. That's it. So I'm going to execute this cell. And then before I save the artifact to the model catalog, I want to make sure that I can test it to avoid any problems down the line. So first I specify, just use as a simple test data set, the first 5 rows of my training data set, and I'm going to convert to JSON. So I'm going to execute this. And then what I do in this cell is I actually import score.py. So I inserted my path, the path to the model artifact, and from there I load the functions load model and predict. And what I do here is I simply load the model to memory, and then I pass a sample payload input data to my predict endpoint. So we're going to execute this. And so what we see here is the loggers. So I'm actually logging the model prediction. There's 5 rows of data, 5 predictions, as well as the input features. So there's 8 features, 5 rows. So this is what we see here. That looks fine. And then we can look at the predictions that my model has made here. If you want, you can compare those values against perhaps a reference set of predictions that your model should return for a particular data set. So that's a good way for you to test the artifact before you save it. I'm going to skip this step here. But once you're satisfied with your artifact, you've tested it, you can simply save it to the catalog. So I'm going to call this sklearnrf2 model. I'm going to execute this. And now we should see this new entry in the model catalog. So I'm going to go back to the console, go to the models page here, and you see here that we just newly created this model object. So we're all good. So the next step is to then deploy this random forest classifier as a model deployment object. So here what I have is a reference to the OSID of my model. So this catalog entry.id, and I'm going to use that to deploy it programmatically. So the first thing I need to do if I want to create a deployment programmatically is to import a data science object from the OCI library. So there's a few different modules here. Data science client composite operations that I'm going to import, as well as some objects that are related to model deployment specifically. So I'm going to execute that cell, and I'm going to use resource principal to authenticate to the data science client object here. So I can use that here because I have created a dynamic group of notebook sessions, and I'm running this particular notebook inside of one of those notebook sessions. So I can use resource principals to authenticate. So I've created an instance of data science client here. And in the next cell, what I do is I create a whole bunch of configuration objects for my model deployment. So the first one is a model configuration details object. So this one is focused on you passing the information about the model that you want to deploy. So this is the model OSID here. For the newly created model entry in the catalog. So I'm just passing this entry, this OSID here. The instance configuration. So in this case, I only want to use a standard 2.1 VM, and I just want to use one of those. And then I select bandwidth for my load balancer. Here I'm going to select a different one, let's say 20 megabit per second. The next configuration is around whether or not more than one models will be used in deployment. So at the moment, we only support a single model. So in this case, you need to create a single model deployment configuration details object. So in this case, a single model, and then you pass the previous object that you've created here. Optionally, you can configure logging as well. Here you just have to provide the logging, the log group OSID, as well as the log OSID for predict and access. So you'll need to pass those to category log details object. In this case, I'm going to skip that part. And then finally, all of these different configuration objects will be wrapped up into a create model deployment details where you need to provide a name for your deployment. So I'm going to give it a slightly different name. I'll call that screencast deployment 1. You give it a description if you want. You assign a project OSID. So it's going to use the same project as the project that's that my notebook session is associated with. And you assign a compartment. So I'm going to use the same compartment as the notebook session. You pass in the model deployment configuration details object, as well as the the logged information as well if you want to. And then those are just configuration objects, and here's the cell that's going to trigger the deployment, the creation of the model deployment object. So I'm going to create a data science client composite operation object here, and this is the create model deployment and wait for state call. So this will take a few minutes to complete. But let's take a look at our deployments page here, model deployments. And so you see here that we should be, yeah, so there's a new model deployment called screencast deployment 1 that's being created. So that's great. All right, so this takes a few minutes to do. So what I'm going to do here is I'm going to stop this cell. And what we're going to do is we're going to invoke a model deployment. So this is the last step in the process. Let me go back to my deployments page here, and we're going to pick one of the deployments that's currently active. So let's say screencast deploy, which is the same model. So we're going to go to the invoking your model, and I'm going to copy this URI. And I'm going to paste it in my notebook. So I'm going to replace this value here. And so let's execute this. So I'm going to first import OCI again. Well, although I've done that in previous part of my notebook, but I specify the URI here. And here again, you have a couple of options to authenticate to the model deployment endpoint. In this case, I've created a dynamic group of notebook sessions that are authorized to make calls to the predict endpoint. So I'm going to use resource principals, so using RPS equals true here to authenticate. And so what I do here is I pass a payload of 20 rows from my training data set. I'm converting that to JSON, and I'm going to use that as payload for my model. So I use the request library in Python, and I'm basically passing in the endpoint, the URI endpoint, the payload data, as well as the authentication mechanism here, which is resource principal. And that's it. I can submit a request, and then I pass 20 rows of data, make predictions in about 400 milliseconds or so. So that completes the end-to-end flow for building, training, saving, deploying, and invoking a model from a notebook session. So you've seen so far you can create a model deployment and how to invoke the predict endpoint. But there's some additional operations that you can take. So the first operation I want to focus on is the edit action. So if you click on edit, you will see a very familiar window. So this is the same window that that is used for creating a deployment in the first place. Edit allows you to change the configuration of your model deployment with zero downtime. And there's a few options that are possible. And as a best practice, we recommend that you apply one change per calls to the edit action. So you can change the name of your deployment. You can change the description if you want. You can change the model. I can pick a different model that I need, perhaps this one. You can change only the shape name and not the number of instances. So maybe I can pick this one instead. And you can also change the logging configuration. So if you want here, you can change a different one and then be good with it. You cannot change the load balancer bandwidth, unfortunately. And then you can submit. So this will apply the changes to your deployment with zero downtime. So while the model deployment is being updated here, you can still make requests to the endpoint. In addition to the edit action, you can also take an action called deactivate. I'm going to go back here to a model that's active here. And you can see here the deactivate option is available. So deactivating a model deployment essentially shuts down the instances that are associated with your deployment. So that includes the VMs and the load balancer. And metering and billing for the model deployment instance and the load balancers will stop when the model deployment is deactivated. So you stop paying for the deployment essentially. And the HTTP endpoint will become unavailable. The model deployment metadata will be saved. And so once a deactivated model can then later on be reactivated through the activate action. And at that point, the same model HTTP endpoint will become available again, and the request can be made to the model endpoint once the model is active. So we have an example of one of those inactive models. So if I click on test here, you can activate that endpoint. So right now it's in an inactive state. You can make calls to that model endpoint. So I'm going to just activate it, and then you can then activate the model, and it's going to take a few minutes, and then the endpoint will be ready to serve requests. So activate and deactivate, or deactivate and activate in this case, are very useful actions you can take. Terminate, let me go back here to an active model. So terminate is essentially stops and deletes the deployment. So at that point in time, you cannot activate a terminated deployment. And if you want to terminate, you will have to confirm that this is really the action that you want. And you may also optionally delete the logs that are associated with that deployment. So you can go back once it's terminated, it's terminated. All right, so that covers the main operations you can do on a deployment. The other one would be to move deployment to a different compartment. So this is another operation that you can take. So edit, deactivate, activate, terminate, and move resource are probably the ones that you will use the most frequently. All right, so this concludes our section on operations that you can apply to model deployments. So how do I get access to OCI data science and model deployment? So the easiest way is to sign up for the free 30-day trial of Oracle Cloud Infrastructure. And so with that, you will get $300 worth of credits that can be used with a variety of services, including OCI data science and model deployment. In addition, you can look at some of the, you can look at our website at data science / cloud infrastructure data science. You can look at our service documentation. You can visit our blog where you get the latest news on our service, nice tutorials, as well as sort of end-to-end use cases. You can take a look at our YouTube playlist and also at our Twitter handle at Oracle Data Science. Thank you so much. And I hope you'll enjoy testing and trying out model deployment.